Kindergarten. Happy Thursday. It's Mrs. Griffith, and today we're going to talk some more about three-dimensional shapes. Okay? We have been talking about several different shapes this week. What's this one? What's the name of this one? It's the sphere. Very good. A soccer ball is a sphere, and it's three-dimensional. I can hold it, I can manipulate it, I can move it. It's three-dimensional. It's not flat, like a two-dimensional plane shape. It's three-dimensional. Then we talked about cylinders. Oh my gosh, I've been finding cylinders all over. I just found this cylinder in the kitchen here. An empty paper towel roll. Oh, and I found another one when I went to put on some lipstick. Your mom has some lipstick. Comes in a cylindrical tube, a container. So I've got my oatmeal, got a canister, got all sorts of cylinders here. Our can of tomatoes. Then we have our cones. Now this is the one that I am having a hard time finding in my house. I have a party hat, but I don't have a lot of cones at my house. But I do have some wooden cones, and I have a foam cone, sorry. So that's another three-dimensional shape. And I have some cubes, a box, a block, and some foam ones, and some wooden cubes. So these are the four three-dimensional shapes we've talked about. Spheres, cylinders, cones, and cubes. And today we're going to compare those shapes. We're going to talk about how are they alike and how are they different. Okay? So if I had you with me at school, we would spend some time putting together this chart. But since I don't have you with me, I went ahead and did this part myself. So we have the cones. That's the first shape on our chart. And when we look at a cone, what do we see? What do we know about a cone? We know that a cone has a point at the top, right? It's got a point and it's got a flat face, right? And then it's got this curved surface that connects the point and that flat face, okay? You see it a little better on this party hat. Point, flat face, curved surface, okay? And then what are some things that look like a cone or are a cone? Well, of course, our party hat is one. An ice cream cone. If you went to Salt and Straw or you went to Baskin Robbins or somewhere, you get a big scoop in your cone, right? When we go out to Carline, what do they put out? Those big orange traffic cones that mark where we stand and where the cars go. Traffic cones, or cones as well. So those are some examples of cones that we see in the world. And I'll bet you found some at your house too. So now we want to look at how can a cone move? Okay, can it roll? Can it slide? Can we stack cones one on top of each other? Those are the questions we want to look at today. Can it roll? Can it slide? And can we stack the shape on top of itself? So let's take we'll use our wooden cones here. And if I wanted to move this cone, maybe I'll come down here to this end of the counter. And if I want to move this cone from here to the other end of the counter, I can take it and I can move it. And it will move across that surface. Is it rolling? Is it sliding? What do you think? Can you see it go? It's sliding, isn't it? It's sliding because it's moving across the surface of my countertop by itself, once I push it, it can keep going for a bit, but it's not changing position on the surface of the counter. It's staying in the same upright position, okay? So on its flat face, I can slide that cone. Now watch this though. I have another cone, and I'm going to take this cone and I'm going to just gently give it a push. And what does it do? It moves again by itself. I don't have to keep pushing and pushing and pushing it. It moves by itself, but is it sliding this time? Or what is it doing? This time, on the curved surface of the cone, it is rolling. It's rolling because it changes position. Okay, the cone is turning and changing position as it goes across the surface of my counter. All right, so that's a roll. That's a roll. And this is a slide. So if I put a mark on the flat base right here, I'm going to put a mark here up at the top. Put a black mark up at the top of my face, and then I'm going to roll it, and you can see how that position of the mark changes, doesn't it? So that tells you that the cone is changing position on that flat surface. You can see that. You can see that mark going around. So the cone can roll on its curved surface, and it can slide on its flat surface. Okay. Now the other question was, can I stack cones on top of each other? Is that going to work? Let's try it. Let's try it this way. Does it work to stack them on top of each other? No, not even this way. No, I can't stack cones one on top of the other, okay? So we learned that cones, they can roll on the curved surface. They can slide on the flat face, but they cannot stack. And I hope you have some cones at home that you can practice that with. Slide some cones around, roll some cones around. See if you can stack some cones. See what happens. Okay, our next geometric shape, three-dimensional geometric shape, is a cube. And I've got lots of cubes here, big ones and little ones and wooden ones and foam ones, okay? So we want to know, can they roll, can they slide, can they stack? Okay, the first ones, I'm going to use my wooden ones because they are the best on this surface. Let's see if we think that a cube can slide. And if we were at school, we would be sliding them back and forth to each other at our tables, but you're going to just have to watch me. But I think it'd be a fun thing to do at home, maybe with brothers or sisters or mom or dad, is practice some of this. So I've got my wooden cube, 6 square flat faces and 8 vertices or corners, okay? Let's see if it can slide. What do you think? Watch. Think it slides? Yeah. it's got a really good slide. It moves along the surface. It's not changing position. It's staying in the same position, but it's moving across that surface, so it can slide. Now, can it roll? What do you think? Do you think that you can roll a cube? Let's try it. Does it roll? No. A cube cannot roll, can it? It can slide on its flat face, but those flat faces cannot roll. I have to keep moving it, don't I? Okay, can it stack? Let's see, can I stack cubes? Got this one, got this one. Ooh, yeah, look at that. And I see you stack cubes at school all the time. Can I put the tiny one on top? Ta-da! Yes, cubes can stack. So, we learned that cubes, they can slide on the flat surface. They cannot roll. But they can stack. All right, next up is what? The cylinders. Let's put the cubes over here. Put these over here. Get these out of the way. Cones and cubes. Now, boy, let's look at our cylinders. We've got a lot of cylinders, lots of different sizes, different items that are cylinders. Okay, so we're going to do our 3 questions. Can a cylinder roll? Can it slide? And can it stack? Okay, first up, can it roll? All right. So, we are going to see if it can roll, and in order to help us see this, I'm going to put, again, a little mark, just a black mark up at the top of the cylinder. And we're going to see if that black mark changes position as this 3-dimensional shape moves. So I'm going to see if I can roll it along. Here we go. Ah, do you see that black mark moving? Yeah, it is moving. It's changing position. So that tells me that on this curved surface, that solid shape, 3-dimensional shape, can roll. Okay? Rolling easily along. Whoop. So, a cylinder can roll on the curved surface. Can it slide? Okay, let's try it again. This time I'm going to put it on its flat face, see if I can slide it. Oh yeah. It slides right along, doesn't it? So it can roll, it can slide. Can it stack? Can I stack these cylinders one on top of the other? I could. Yep. So I can stack them. So cylinders are pretty cool because they can do all 3 things. They can roll, they can slide, and they can stack. So a cylinder can roll on its, which surface does it roll on? The curved surface. It slides on the flat surface. And they can stack too. All right, See if you can stack some cylinders at your house. And then last but not least is our sphere. Our spheres. So, can they roll? Can they slide? Can they stack? Okay, so let's see if we think this can roll. Do you think this ball can roll? Yes. Woo! Yes, it can. It rolled right off the countertop. So we can roll. And if you look at this little writing here, you'll see it. Whee! Moving along. So the sphere has only a curved surface, doesn't it? Only a curved surface. It doesn't have any flat faces. So when we move a ball, it is rolling, isn't it? It's going to be rolling. It's not going to be sliding. It's going to be rolling. Can we stack spheres? I don't know. What do you think? I don't think it's going to work. Why not? Why won't they stack? They don't have any flat face, do they? They don't have any flat surface, like a cylinder or a cone. So they can't, or a cube. So they can't stack. Okay? So let's record what we found out about spheres. They can roll. They don't slide. And they don't stack. Okay? All right. They need one flat side to slide. They need two flat sides to stack. And to roll, they have to have a curved surface, don't they? All right. So, our cones, our cubes, could be blocks, could be boxes, could be dice. Cubes can slide. They cannot roll. They can stack. Our cylinders could be a soup can. Could be a glass that you drink out of. Could be a marker. This is a cylindrical object, a cylinder. They can roll on the curved surface. They can slide on their flat surface. And they can stack. And then finally, our spheres. Balls are spheres. Big round balloons can be spheres. Marbles can be spheres. They can roll. They don't slide. And they don't stack. Okay? Get out some of these 3D shapes at your house and try rolling them, sliding them, stacking them. Have some fun with your three-dimensional shapes. Now here's one more thing. Tomorrow when you come to reading group, I would like you to bring a three-dimensional shape, just one, from your house. Okay? Small enough that you can show it to us. And I want you to show us the shape that you found, and then I want you to tell us how you know it is a cone, or how do you know it is a cube, etc. So be ready to tell us about that. Okay? See you tomorrow, kindergarten. Bye.